Before going to the atomic structures, let us discuss a few quantities. That are essential to understand this. Now, one is the magnetic field. It will be given by the letter B, and its unit is Tesla or Weber per meter square. Now, the magnetic flux, that is the magnetic field times the area B dot A, that is will be Weber. Then magnetic moment, mu, it is joules per Tesla, okay, or Bohr magneton. And Bohr magneton is given by mu B. This is another unit of measuring the magnetic moment, mu B, which is given by EH cross by 2m. Some other units for magnetic field are Newton second or Coulomb meter. And mu naught is permeability. It has nothing to do with the magnetic moment. Permeability, that's 4 pi into 10 to the power minus 7 Weber per ampere meter. And the H cross unit is joules second. Fine structure. So what do you mean by fine structure? It is splitting off the L value into multiplet. That is, it can be either doublet or triplet. Due to the spin orbit interaction. Okay, so this is basically due to LS coupling. So the L value is being split into two states. So this particular splitting is called fine structure. Now assume that here we have the atom, the center, and electron revolving around it. Now, due to orbital motion, is in this way, and due to this orbital motion there is magnetic field at the center. So here you have the magnetic field. Field is produced at the center. Now why there is magnetic field at the center? Because there is an electron motion, which means there is current I flowing in circular path. You will have the magnetic field. If the current is in this anti-clockwise direction, the magnetic field will be in this particular scenario is outward. So you will have outward magnetic field. So that is the direction of the magnetic field. So here there is due to the electron is also having the spin, and due to spin motion, there is magnetic moment mu s. So due to spin motion, there exists magnetic moment. Moment mu s. So here there is a vector mu s, and here you have the magnetic field vector b. Now the interaction of the magnetic field b and mu s, the magnetic moment mu s, give rise to an interaction potential. Give rise to a interaction potential and that interaction potential energy is given by minus mu s dot b bar, and the value of mu s is equal to minus gs E by 2m into s, and now the magnetic field at the center, that is the magnetic field at the center is let us write center as given by z e by 4 pi epsilon naught r cube into 1 divided by mc square L. So this is the magnetic field at the center, and to calculate but we need the magnetic field not at the center but at this particular point, because here is what we have the vector L, and we need the value of the magnetic field here. Now assuming that in the first case the electron was moving and we had the magnetic field at this point, now in the frame of reference of the electron, it assumes that according to this electron, the nucleus is moving around, right? So nucleus will have a positive charge and it is moving around the electron, just like the concept that it was assumed that sun is moving around the earth. Okay, so but it came later, it was stated that earth is moving around the sun. So it is just the reference frame, okay, frame of reference. changes. All right, now but now we know that both sun and earth are together moving to somewhere. Yeah. Now we have come to this conclusion that when this nucleus is moving around this electron, a nucleus is a positive charged particle, and when it moves around the electron, there is a magnetic field at this electron also, and the magnetic field at the electron, so we will write electron here, will be equal to half the magnetic field of Bc. That is the magnetic field at the nucleus. So just substitute this half of Bc at n, or yeah, at here you would get the potential energy, which is interaction potential. So considering the interaction potential, the magnetic moment and the magnetic field, you can write the potential energy of the interaction is equal to the Hamiltonian H dash, which can be written as ZE square divided by 8 pi epsilon naught m square c cube 1 divided by r cube into L dot S. So 1 divided by r cube expectation is equal to z cube divided by n cube a naught cube L into L plus half into L plus 1. So L dot S expectation is equal to half h cross squared into j into j plus 1 minus L into L plus 1 minus S into S plus 1. So this is L dot S expectation, this is 1 by r cube expectation. So the energy is equal to expectation of H dash, which is equal to this term plus the expectation of this and L dot S. Now that can be written as RCH alpha square z cube z power 4 divided by n cube L into L plus half into L plus 1, that's equal to times this L dot S, so times half into j into j plus 1 minus L into L plus 1 minus S into S plus 1. The value of R alpha square is equal to 5.84 centimeter inverse, where R is the Rydberg constant and alpha is fine structure constant. So the energy E due to LS coupling is equal to R times CH alpha square Z power 4 by N cube L into L plus 1, sorry, L plus half into L plus 1 dot half J into J plus 1 minus L into L plus 1 minus S into S plus 1. Now dividing by the CH, that is this particular value, we will get the ELS in centimeter inverse, or this is called term value. Term value or wave number. Wave number. So ELS in terms of centimeter inverse will be given by, so just divide this equation 1 by CH will give you R alpha square Z power 4 by N cube into L plus half into L plus 1 times half the value of J into J plus 1 minus L into L plus 1 minus S into S plus 1. Okay. Now due to ELS coupling, here you have the L state, and due to the ELS coupling we have a state something like this. This splitting is called the fine structure. So here S is equal to half. Now you will get J equal to L plus half here, and here J equal to L minus half. So then just substitute the value of J equal to L plus half and J equal to L minus half over here. You will get two states, energy of this particular state. If you write E plus and here you write E minus, and this energy gap is the delta total with respect to this this original state. The delta total, that is the total delta for the energy ELS, is given by, so delta total is equal to R alpha square Z power 4 divided by N cube times L into L plus 1. Now what you have to remember from this formula is the energy delta is proportional to delta LS is proportional to 1 divided by N cube, inversely proportional to the cube of the state or the principal quantum number En, and delta LS is proportional to 1 divided by L into L plus 1. Okay. Now delta LS is proportional to Z power 4 if the structure has the atomic number Z. If it increases by two times, then the delta LS would increase by 16 times. Okay. So this is also written as delta EJ, that is the change in energy due to the J value and due to LS coupling. the energy of ALS coupling is equal to R alpha square Z power 4 by N cube L into L plus half into L plus 1 times half into J into J plus 1 minus L into L plus 1 minus S into S plus 1. So this is the energy of the ALS coupling for one of the states, any of the states. Now we can see that if this one can be written as ELS. Now this entire term we can write it as A. This particular term can be written as A, so that becomes A into 1 by 2 into J into J plus 1 minus L into L plus 1 minus S into S plus 1. Now this is like this. The L is splitting into, for S is equal to half. This becomes J equal to L plus half, sorry, L minus half, and this becomes J equal to L plus half. Okay, so for the first one and second one there is an energy gap. So at J equal to L plus half, we have the energy for J equal to L plus half. So wherever you have J, you have to substitute it by L plus half. So you will get when you substitute for J equal to L plus half here, and S is equal to half here, put J equal to L plus half and S is equal to half. So what you're going to get is A by 2 into everything get cancelled, you will end up with only L. Now similarly for energy at J equal to L minus half, what you have to put is J equal to L minus half and S is equal to half. Now in this case what you are going to get is A by 2 with a minus sign, minus A by 2 into L plus 1. Now this is EJ with L equal J equal to L plus half, and this is EJ with the EJ with the J value equal to L minus half. Now what is delta ELS? Is nothing but the energy gap between these two, that is, let me write E plus minus E minus. Okay, this is L plus half and this is L minus half. So the difference between these two energy level energy is delta ELS or delta EJ. This is also you can write as delta EJ, which is equal to A by 2 into, because A by 2 is common, minus of minus will become plus, so it will become 2L plus 1. 2L plus 1. This you can write it as A times bring this L, so L plus half. So L plus half is nothing but J, so A times J. So this is J corresponds to plus half. So L plus half is nothing but, we have already seen that if this is J, this must be J plus 1. If this is J, this has to be J plus 1. So L plus half represents J plus 1. So A times J plus 1, that is the delta EJ. Landay's interval rule. Now if there is a level L with the S is equal to half, then due to LS coupling there are two energy levels formed due to the splitting. So this is equal to J equal to L plus half, and this is J equal to L minus half. Now if this value is equal to J, then the upper value will be equal to J plus 1, because this is L minus half. If you want to reach L plus half, you have to add plus 1. Now Landay's interval rule suggests that the energy difference delta EJ, that is the energy difference between these two energy states, is equal to A times J plus 1, or A times the higher J value. Higher J value is here J plus 1. Now where A is equal to R alpha square Z to the power 4 divided by N cube L into L plus half into L plus 1. Now the separation between these two states is equal to the higher J value. That is, the Landay's interval rule says that the separation between fine structure level is directly proportional to higher J value.